Hello everyone, I am Vivek Kamboj, a first semester student in the Master in Construction Engineering and Management program at CEPT University. Now I will be presenting my portfolio for studio course Construction Project Formulation and Appraisal. The project I have formulated and appraised is the Shastri Bridge Redevelopment Project in Ahmedabad, Gujarat. Starting with project background, the Shastri Bridge is a critical infrastructure asset connecting NH47 to NE1. Currently, the existing four-lane bridge acts as a severe bottleneck due to heavy industrial traffic from the Vatva GIDC and local commuters. A proposal is to redevelop this obsolete structure into a eight-lane bridge. Coming to choosing by advantage, we started with technical formulation. For a project of this scale, simple decision making isn't enough. We employed choosing by advantage methodology here. This method allows us to make decision based on IOA rather than just comparing pros and cons. We identified two major construction problems based on stakeholder perspective. The first problem is selection of material for girder for the new 8 plus 2 lane bridge superstructure. The other problem is choice of formwork material for pile, pier, and pier caps construction. For problem 1, selection of superstructure material, we had to choose between PSC girders and UHPFRC girders. UHPFRC is technically superior with a compressive strength of 150 MPa and it reduces the number of girders required by 20%. However, when we compare the cost, UHPFRC stands at 80,000 per cubic meter, whereas PSC is significantly lower at 7,000. Through this, we selected the PSC girders because it offered the optimal value. It satisfies the 100-year design life required by NHI and provides a proven durable solution at a fraction of cost, which is economically justified choice for our project. For problem 2, which is selection of substructure formwork, the second decision was choosing between aluminum formwork and mild steel formwork. Aluminum is lighter and offers higher repetition. However, for bridge piers, we need high load bearing capacity. MS formwork offers 100 to 150 kN per square meter, which is far superior for heavy civil structures. We selected mild steel formwork as it costs 6,000 per square meter compared to aluminum, which is 9,500. Since we need robustness over speed for the substructure, MS formwork delivered the highest advantage per rupee spent here. Moving on to bid process management, the core philosophy of government infrastructure procurement is risk transfer. The client want to shift the execution time and cost risk to the private party. We have allotted four models here: item rate, percentage rate, HAM and EPC model. We compared them on factors like revenue suitability and risk management. The Shastri Bridge is a standalone urban connector. It does not have a toll plaza. In HAM model, the private concessionaire relies on annuities which are often linked to traffic performance or long-term maintenance. Without direct revenue, the financial structure of HAM model is weak here. EPC is a turnkey model. The authority agrees on a fixed lump sum cost and a fixed time. The contractor takes the risk of material price fluctuation and design efficiency. This minimizes the oversight burden on the authority. We then define the procurement strategy for the key project players. The first one is feasibility consultant. The selection method will be QCBS 70-30, where 70% weightage will be given to technical and 30% will be to the financial. The feasibility consultant will be preparing detailed project report, which is a blueprint of the project. If the survey or design is flawed, the project fails. Therefore, we prioritize technical experience over the lowest bid here. For EPC contractor, the selection method is least cost selection. Unlike the consultant, the contractor has to follow a rigid set of drawings and NHI standards. The scope is defined here. Therefore, the L1 bidder is the most beneficial for public authority. The estimated project cost is 119 crores. Repeat security will be 1%. Performance security will be 5%. The scope of work under the contractor is construction of new two-lane service carriageway, demolition of old two-lane service carriageway, construction of new eight-lane carriageway, rehabilitation of old two-lane service carriageway. Since the project is executed over Sabarmati River, the environmental and safety risks are high. So we drafted 14 specific special conditions of contractor that the contractor must adhere to, which are coffer dam works, seasonal restrictions, waste compliance, segregation of waste, zero disposal policy on the river, storage limits, accidental discharge on the river, permissions, advance notice, traffic management plan to be prepared by contractor, demolition methodology to be prepared, river protection, hazardous materials, and recycled concrete usage on the project. For independent engineer, we shifted the QCBS ratio to 80:20. The eye is the authority, eyes on the ground. They must have high technical strength to oversee complex tasks like deep pile foundation and girder launching. We cannot compromise supervision quality for a lower fee. The IE supervises the work and ensures quality control. Their payment is strictly linked to the submission of monthly status report and ensure they remain accountable throughout the 28-month construction period and defect liability period, which is 10 years long. Looking at economic feasibility, it is crucial to understand that this is a public project. Private projects are driven by profit. Public projects are driven by social welfare. We don't get returns in form of cash. Rather, we get returns in form of savings to the public. To quantify this, we use the cost-benefit analysis guidelines from IRC-SP 30 and IRC-SP 54. The assumption for economic analysis for project are period of analysis is 20 years, discount rate is 12%, construction period is 2.5 years, total civil cost for project is 147.5 crores, and schedule for payment for the contractor is done based on milestones. For cost benefit analysis, we calculated the vehicle operating cost. This represents the cost of fuel, wear and tear, and time of vehicle to be used by the road. We compare two scenarios here. The first one is without project, the base case, the existing 4-lane bridge remains here. The second one is with project, where we are building the 8-lane bridge, which will elevate the congestion, speed will increase here, and VOC will decrease. We utilized the actual traffic vehicular count from 2022 to 2023. We forecasted the traffic using the Gujarat specific growth rates to the project operational year, which are 2028 to 29. In the year 2028-29, the total VOC without the project is 31.61 crores. With the project, it drops to the 24.08 crores. The difference is 7.52 crores in our economic benefit for the year 1. We then plotted these costs and benefit on the timeline. Cost outflow. This include the total civil cost of 147.50 crore disturbed according to EPC milestone. We also factored in annual O&M cost and ad revenue cost. For benefit calculation, the annual savings in VOC and time multiplied by PV factor to bring them to the present value. The inflows of the project is calculated. For sensitivity analysis, we tested the project against risk. Case 1 base scenario, the economic internal rate of return is 7.30%. The case 2, if traffic or saving increased by 10%, the EIR jumps to 8.43%. This proves the project is highly sensitive to utilization. If people use it, it pays off. For case 3, the increase in 10% of O&M cost if maintenance become expensive, the EIRR drops to 7.20%, emphasizing the need of durable materials we selected earlier. Finally, the benefit cost ratio, when calculated for standard 20-year period, the ratio is 0.56. This is technically below 1, suggesting the cost outweigh the quantified benefits in short term. However, bridge are 100-year asset. When we extended the analysis to 30-year horizon, the BC ratio improved drastically to 0.93. This tells us that while the upfront investment is heavy, the project is long-term asset. Its value isn't instant. It accumulates over decades to service of the city. Finally, coming to our conclusion slide, for choosing by advantage, we did not just pick up the best technology, we used CBA to pick up the optimal technology, balancing performance with public funds. For bid process management, we structured an EPC contract to shield the client from risk and drafted detailed SSCs to protect the Sabarmati River ecosystem. For economic analysis, we demonstrate that while the immediate financial returns are low, the project is a vital piece of urban infrastructure that becomes economically viable over its true operational lifespan. Thank you.